Assalamu alaikum students. This is Dr. Munir Omar with CS222 Database Management Systems. In today's lecture, we will be studying about keys and relationships. This is with the continuation with our previous lecture, which was about ERD, Entity Relationship Diagram. These are the main contents of our today's lecture. First, we will look into relationships, then types of relationships. After that, we will have keys in tables. Why do we need keys and some types of keys? So, what is relationship? Relationships are the connections and interactions between the entity instances. Suppose we have two entity types, student and location, and these two entity types are needed to be connected. The instances of students are connected with the instances of location. Here, if you look into these two tables, the instances here are connected with the instances of this table. So this association is known as relationship. The symbol used for relationships is a diamond symbol, and if we need to connect two entity types, then we use the diamond symbol in this way. Here, the department has relationship with employee table or the employee entity type, and here the student has relationship with book. So all the instances inside the department will have association with the instances of employee table. Similarly, the instances of student will have association with the instances of book table. We have two entity types here, student and location. Student is an entity type. We can say that it is a table. It has some attributes, and location is also a table having some attributes. So by relationship, we mean that the instances of the students, which are these, are connected with the instances of location table. So now if we look into Ali, this Ali is belonging to cohort, and if we look into this table, there is no cohort entry against Ali. So how can we get this? Against Ali, the zip is 26,000, and this 26,000 is also present in the location table. So these two values under zip can be used to connect this Ali with the rest of values in this row. So we can say that this Ali belongs to cohort, KPK, and Pakistan, and we got these values through this zip, which is common in both the tables, or we can say that this zip connects both the tables. So here the zip is actually a foreign key, and this zip is primary key. This foreign key is used to connect both the tables. So this student belongs to location. To identify the relationship between these two entity types, we must have a diamond symbol here, which is used to show the relationship between entities. We may have some other symbols along with this diamond between the entity types. These symbols will be discussed in our next lecture, which is about cardinality and modality. There are three major types of relationships. The first one is one-to-one relationship. Then we have one-to-many, and the last one is many-to-many relationship. By many, we mean two or more than two. And here we typed it as M2N, not M2M, because the number of instances can be different, but both would be under many case. Now we have examples of one-to-one relationship. So the first example is a student belongs to only one program. Second one is a student has only one ID. And the last one is an employee has only one computer assigned. There are many other examples, and you will find different entity types having one-to-one examples, like employee can have only one vehicle. Student with chair, this is also one-to-one relationship. Faculty working in only one department. Faculty having only one office. Department has only one HOD. Program has only one director. University has only one location. City has only one zip. And there are many other similar cases. For one-to-many relationships, we can say that a division could have more than one program offered. In one department, we may have many programs, like in our department, we have BS Computer Science, BS Software Engineering, MS Computer Science, and PhD in Computer Science. Program could have many students enrolled. In one program, we can see that there are many students registered. There are many other cases. For example, a student can register in many courses. A teacher can teach many courses. A city can have many schools. A department can have many faculty members. An employee can have many children. A program can be divided into many semesters. There are lots of similar examples available. Then we have many-to-many relationships. Students could take many courses, and a course could have many students. An author could have many books, and in a single book, there might be many authors. A music album could have many artists, performers, and an artist performer could have many albums. So these are the examples of many to many relationships. Some other examples are a person can visit many cities, and a single city can have many visitors. A player can play in many games, and in a single game there might be many players. A plant can be grown at many places, and a single place may have different type of plants. So there are many other examples. You can search such examples by studying this topic. While working with relationships, we also name these relationships. So there is no proper system, or there is no proper rules for naming the relationships. However, it is suggested to give appropriate names to the relationships according to their contexts. If there is no proper name available for association in the system, then participants' names of abbreviations are used. For example, we have an entity type, student, and the second one is class. So for this, we can use enroll as a relationship word. Student enrolls in a class. So if suppose we haven't this word, then we can also use this set of abbreviations as a relationship name. There is one another thing, that is a relationship type. So it can be identified like an entity type, as we know that we use the relationship between two entities. Here we have diamond, and we have two entities, and in between we have a relationship. So we know that these entities may have some attributes. Similarly, here this one will also have some attributes, and this relationship can also have attributes just like entity type. A relationship type is an abstraction of a relationship. The entities involved in a relationship are called participants. So here we have relationship and two participants are two entity types. Example of this scenario can be here. Suppose we have student, and this one is, let's say, course, and this one is register. So we may have some attributes for students like ID, name, further name. For course, we may have course ID, number of credit hours, title, and for register, we may have the registration ID, date of registration, etc. Then we have key in a table or keys. A key in a table is a field or group of fields that create identity, makes relationship with another table, and or make a table more efficient. Actually, we use key for identification of records, for unique identification of record. Key is a column or an attribute of an entity type. So there might be some columns which may have unique values for all the rows in the table. Suppose we have a table storing the students information. So in the student information table we can say that the registration number, which is an attribute or a column, gives unique values for all the records. It cannot be duplicated. So why do we need a key? Actually, key is used to identify any row of data in a table. In general applications or real world application, a table could contain thousands of records. Moreover, the records could be duplicated. Keys ensure that you can uniquely identify a table record despite these challenges. Suppose we have a table having names of citizens, let's say students, and there are 5 students in the list. Then it is possible that we may not get two same names in the table, but if we have a big number of students in the table, let's say 5,000, then it is obvious that there would be many duplicated names. So for this purpose we must have one additional column so that the additional column may uniquely identify the students. As you know that we are using enrollment number or registration number, which are unique, and with the help of this registration number we can easily identify a student. The second thing about keys is relationship establishment. With the help of keys we can make a relationship between tables. Also, by using the keys we can enforce identity and integrity in the relationships. The first type of key is super key. A super key is a group of single or multiple keys which identify rows in a table. Super key may have additional attributes that are not needed for unique identification. Now here in this table we have EMPSSN, which seems to be an attribute having unique values, and also the employee number will have unique values, and this employee name may not have unique values. Some names may repeat under this EMP name. So if we say that this attribute gives unique identification to the records, to the rows, then this can be said as a super key. Same is the case with this one. But here one thing should be noted, that a super key may have more than one columns like this. we can combine two or more columns to make a super key. So this is also a super key. This one is giving uniqueness, but not this one. But the combination of both is also giving unique values, because we will have unique combination like AB05 shown will not be repeated throughout the entire rows of the table. Then we have primary key and foreign key. A primary key is a key that uniquely identifies a row in each table. It is normally denoted with its first two letters, namely PK. Primary key is a minimal super key. Now here, this one is super key. It has one additional attribute. Now if I minimize it to the possible level, then it can be said as a primary key. Foreign key is a key borrowed from another related table in order to make the relationship between two tables. It is denoted by FK. Now here we have two tables. This Y is used to connect this table with this one. Now suppose we have some values in this table. These can be said as the instances of this entity type or this table. These instances can be accessed by the values under X here through this Y. This Y is known as foreign key, while here this Y is the primary key. Some rules for defining the primary key. Two rows can't have same primary key values. Suppose we have student ID here. So under student ID, the values must not be repeated. This one must not come again. The second thing is every row must have a primary key value. So the value must be present here. It must not be null. Third thing is the primary key value cannot be modified if it is connected with a foreign key. Suppose here we have 5 and here we have 5. So this 5 cannot be changed if we now here this record is connected with this one. So if we change it to 6, so what will happen? This link will be broken and we may get some sort of undesired connection among these records of two tables. Then we have alternate key. Before alternate key, let's look into the candidate key. A super key with no repeated attributes is called a candidate key. We have the same definition of primary key for the candidate key. The primary key should be selected from the candidate keys. Suppose we have a table just like this. There might be many attributes which could be made as primary key. Now if we look into this table, student ID, roll number and email, these attributes seem that they are not giving duplicated values. So we have these three candidate keys. The primary key is selected from the candidate keys. So we can select one key from these three and make that key as a primary key. Now the alternate key, what does alternate key mean? Alternate key mean that the key which is not primary key but that key has the features of primary key. In simple words, we can say that the candidate key which is not selected as a primary key. Properties of candidate key. We have same properties of primary key for the candidate key. It must contain unique values. The candidate key may have multiple attributes, means that we can combine two or more attributes to form a candidate key. Now, if I say that email plus last name, this is a key, so this can also be said as a candidate key because the records would be unique throughout the table due to this email. Must not contain null values and minimum field to ensure uniqueness. We will try to reduce the number of attributes in a candidate key to ensure uniqueness and uniquely identify each record in a table. So these are the properties of candidate key. Only one property of primary key is missing, which was about the foreign key connection. Now look into this table. We have student ID, roll number and email. These three attributes are giving unique values to all the records. First name and last name may repeat. We may have Tom somewhere in this table again. Same, we may have price here again. So these values may be repeated. These are not unique. However, the student ID, roll number and email, these are unique and these cannot be repeated. Now these three can be said as the candidate keys. If we choose a key from these three, then that would be primary key. Or we can say that the primary key is chosen from the candidate keys and the remaining candidate keys are called as alternate keys. STD, student ID, is now primary key and roll number, email, these two are now candidate keys and also the alternate keys. Next we have compound and composite keys. There is a minor difference between compound and composite keys. Both are the combination of two or more attributes in a table. Sometimes the attributes don't give uniqueness in the table, so what we do, we combine attributes to get unique rows in the table. Now if we look into this table, the order number and product ID, these can be combined to get unique records. Now under order number, B005 is repeating. Also under product ID, this value is repeating. Here DKT is repeating, so this might also repeat. Now if we combine these two attributes, then these combinations will not repeat in the table. Throughout the table we may have thousands of records, so these combinations would not repeat. This is known as compound or composite key. The combination of two or more attributes is known as compound or composite key. But what is the difference between compound and composite key? The difference between compound and composite key is that any part of the compound can be a foreign key. There is a condition that in case of compound key, one or more attributes should be foreign key, but in case of composite key it is not necessary. Now if I say that this is compound key, then either order number or product ID is a foreign key in another table. Means that one of these key is used to connect the records with other tables in case of compound key, while in case of composite key this foreign key is not necessary to be present in these two attributes. We may have more than two attributes, so for compound key, among those attributes there must be an attribute which is connected with a foreign key, while in case of composite key this condition is not necessary. We can say that a compound key can be a composite key, but a composite key cannot be a compound key. Then we have surrogate key. Sometimes we may have a table in which there is no such attribute which can be made as a primary key, or simply we can say that there is no candidate key in the table. So for that purpose we create an artificial key with the aim to uniquely identify each record in the table. That new key don't have meaning, but the main purpose of the key is to provide uniqueness so that each row may be uniquely identified. So we can add an additional column in the table with some numbers in a sequence that may give uniqueness. So here I'm adding ID, and under ID we have a series of number. For each new record a new number is added. These numbers are now unique and each row can be uniquely identified with these ID numbers. In most of the cases we use an integer value for surrogate keys. Why do we use surrogate key? If there are no candidate keys in the table, or the candidate keys or super keys are too big or complicated. Now if I combine all these attributes and make a composite key, then we may get unique combination, but this would be very complicated, and this is a very big key. So to avoid such type of situation, it is better to use a surrogate key. Thank you.